All right, this is part one of the review for the the final. So in the first question, we're trying to solve the compound inequality and then graph its solution. For this first one here, when it says 2v is less than -4, when divide both sides by 2, a lot of people get it mixed up and feel like they need to change the direction of the inequality. If I was dividing by a -2, that would be true. But if I'm dividing by a +2, this is going to stay v is less than -2. Then I have or, and then v plus 10 is greater than or equal to 9. Subtract 10 on both sides. V is greater than -1. So v being less than -2 would be like a parenthesis. If you use the open circle, you could do it that way. And then v is greater than or equal to 1. For number 2, x is less than or equal to 0. Or x over 5 is less than or equal to 0. Multiply both sides by 5. X is less than or equal to 0. 4x is greater than or equal to 20. Divide by 4. X is less than or equal to 5. Oh, I did not mean to write the 5 here. So in both these examples, it's or. If it was an and, then you need to talk about the overlap of these was. But for x being greater than or equal to 5, the arrow's going in this direction. Less than or equal to 0, I'm going in this direction. For number 3, it's asking us to solve the equation. So it says the absolute value of -7 minus m is equal to 67. So I'm going to deal with the positive case. Right, add 7 on both sides. -10m is equal to 74. Divide by -10. M is equal to, now I can divide both the -10 and the 74 by 2. So this is going to be 37 over 5, and it's a -37 over 5. The second scenario is that -7 minus 10m is equal to -67. So here I'm going to add 7 on both sides again. -10m is equal to -60. And divide both sides by -10 to get m equals 6. For number 4, we talked about when we see a scenario where the absolute value is less than or equal to, we can rewrite this like 5x is less than or equal to 15, and then less than or equal to -15. Now, I think some people, because there's the difference between the two, aren't going to approach it like that. So we can look at this first part. 5x is less than or equal to 15. Divide both sides by 5. X is less than or equal to 3. If I'm going to change the sign of the 15, then I need to change the direction of the inequality. X is greater than or equal to -3. So x is greater than or equal to -3 and less than or equal to 3. So we can think of that like an and statement. Again, you could set this up like -15 is less than or equal to 5x is less than or equal to 15. For number 5, the absolute value, so -8 plus k is less than 2. K is greater than 10. negative 8 plus k is less than negative 2. I'm going to add 8 on both sides. K is less than 6. So I have k is less than 6, or k is greater than 10. Number 6 is asking us to identify the domain. We're setting the denominator here equal to 0 and figuring out which x values we should exclude. So it's going to be all real numbers except negative 1. Because I don't want a 0 in the denominator. That was number 6. Number 7 is asking us to simplify each expression. So it's 4v squared minus, or over 2v minus 14v divided by 2v. 4 divided by 2 is 2. V squared divided by v is v minus, or I'll think about this like plus the negative. So this is plus a negative 7, or 2v minus 7. Don't worry about stating the excluded values. It's kind of like what they just asked us for the question in the domain, but I'm looking for simplifying for numbers 8, 9, 10. In this example here, we're looking for two numbers that multiply to a negative 7 that combine to negative 8. M minus 1 times m minus 7 divided by m minus 7. I can rewrite this like m minus 1 as a final answer. In number 9, we're multiplying x squared plus x minus 12 divided by x squared minus 12x plus 27 times x minus 2 over x plus 4. The x squared plus x minus 12, I know I'm multiplying two numbers, where one is negative, one is positive. When I combine them, there's going to be I have positive 1x left over, so I'm thinking plus 4 minus 3. In the denominator, I'm looking for two numbers that multiply to 27 that combine to negative 12. They're both going to be negative. This is x minus 3 times x minus 9. And I can cancel x minus 3 with x minus 3. X plus 4 with x plus 4. I'm left over with x minus 2 in the numerator. And x minus 9 in the denominator. With number 10, because I'm dividing by, or I've got a fraction divided by a fraction, some people write keep, change, flip. I'd probably set this up like I'm multiplying by the reciprocal. So I'm multiplying, and now n plus 3 is in the numerator, and n plus 9 is in the denominator. I can rewrite that 10n plus 90 as 10 times n plus 9. The n plus 9 and the n plus 9 cancel. Some people are going to want to cancel these here. You can't do that. You have to see the same, binomial in the numerator. So this looks like 10 times n plus 3 divided by n minus 3. So that was number 10. In number 11, we looked at some of the, as they describe, like the complex fractions. In this example, it's similar to number 10. I have a fraction divided by a fraction, right? If I had a over b divided by c over d, I could rewrite this like a over b times d over c. Like I can multiply by the reciprocal. And I'm going to do the same thing here. M minus 3 over m times m minus 2 over m minus 3. M minus 3 and m minus 3. I'm going to cancel out. I'm left with m minus 2 over m. For number 12, I would do polynomial long division. The order is going to be divide, multiply, subtract. Then we're going to bring these down. So x minus 1, 6x squared minus 11x plus 8. I am dividing 6x squared by x to get 6x. I'm then multiplying 6x times x minus 1. So I can put a 6x here. This is going to be 6x squared minus 6x. And then I'm subtracting 6x squared minus 6x squared is going to be 0. 11x, if I'm subtracting a negative, it's like negative 11x plus 6x squared. This is minus 5x. And now I'm going to bring down the plus 8. So I'm dividing negative 5x divided by x to get negative 5. Minus 5 here. I'm multiplying negative 5 times x minus 1. Oh, sorry, negative 5x plus 5. When I subtract negative 5x from negative 5x, I'm left with 0x. And 8 minus 5 is going to be 3. So this is 6x minus 5 plus the remainder of 3 over x minus 1. In both 13 and 14, the index is 2, right? If there's no number written there, we're trying to find the square root. I'm not as worried about the numbers. Like 108, I know it might not be obvious about what I could factor out from here. And I think you guys could probably work with smaller numbers. What I want to talk about here is the square root of n cubed first. I'm looking for perfect squares, like n squared times n. And this would be like the square root of n squared is going to be n. So I can rewrite this like the square root of n squared times the square root of n, or n square root n. I think there was some confusion when we looked at larger exponents. So like the square root of n to the 7th. I'm going to think of this like n to the 6th times n. Someone in class brought up how it's almost like we're dividing the exponent by 2. And the fact that 7 is going to have a remainder of 1 over 2, that's that degree of 1 being stuck here. And then 3, you can write this like the square root of n to the 6th times the square root of n. This is n cubed square root n. With 108, I might start with looking at what numbers multiply to 108. So 100 divided by 2 is 25. Or sorry, 100 divided by 2 is 50. So this would be 54. Numbers that are divisible by 3, we should be able to add up the digits and get a number that's divisible by 3. So the fact that 1 plus 0 plus 8 is divisible by 3 tells me I can rewrite this like 3. 99 would be 3 times 33. If I'm adding 9 to that, I'm adding 3. This would be 3 and 36. 4 is going to be 27. It's not divisible by 5. It will be divisible by 6. And 18, not divisible by 7. For 8, because it's 4 and 27, I can't divide 27 here by 2, or write 2 as a factor. And then for 9, this would be 9 and 12. And now I've written all the ones here. So I see 4 is a perfect square, 9 is a perfect square, and 36 is a perfect square. My point is, it's going to be the easiest to work with, thinking of this as 36 times 3, or the square root of 36 times the square root of 3, 6 square root of 3. But even if you didn't find the largest perfect square, if you rewrote it like 4 times 27, and this was 2 square root 27, that will work as long as we understand that when I rewrite the square root of 27 as the square root of 9 times 3, or 2 square root 9 times the square root of 3, I'm multiplying whatever the square root of 9 is by 2. I had some people that were making all the right steps, but then adding. So this is like 2 times 3 times the square root of 3, or 6 square root 3. So altogether, this is going to be 6n square root 3n for 288. I know that 12 times 12 is going to be 144. So this is like the square root of 144 times 2, or the square root of 144 times the square root of 2, 12 square root 2. And because b is in the inside the radical and it's only has a degree of 1, I can write this like 12b square root 2. And I think that's the last problem. Yep. All right, so that's the last problem for part 1. I'm going to post a part 2. If you have any questions, don't hesitate to reach out to me. Again, the exam is going to be on Monday, and let me know if you need anything.